In this video, we're going to be working out two rotational kinematic problems, the first one with a merry-go-round and the second one with a circular saw. So let's go ahead and start with the first one. Merry-go-round starts from rest and is spun with an angular acceleration of 0.05 radians per second squared. A kid rides for 12 seconds while sitting 2 meters from the center. Solve for the final angular velocity, and linear acceleration. So we want the omega f, we want the v, and then we want the a eventually as well too. So let's go ahead and label what we got. We know that the starting angular velocity is 0 because it starts from rest. We know the alpha value, 0.05. And we know a time of 12 seconds. And then our final thing, it's sitting 2 meters from the center, which would imply that is our radius. All right, now with those different values, we can go ahead and find omega f. We can go ahead and use the formula final minus initial over time equals alpha, and it looks like we have all the variables we need to find that unknown. So let's go ahead and find the omega f first. All right, so all we had to do is multiply both sides by 12, pretty simple operation, and we came out with 0.6 radians per second. Now for our second one, we want to find the linear velocity. If we want to find the linear velocity, then we would end up using the formula v equals r times omega. So that ends up being a fairly simple calculation too, because we have the r value of 2 meters. We just found our omega of 0.6. All we have to do is multiply those two, and we got the product of those two at 1.2 meters per second. And then for our final one, we're going to use one more formula to translate some of our angular stuff into linear stuff. And we have the linear acceleration equals r times alpha. So we're going to take our radius of 2 meters again, grab that alpha from earlier, the 0.05, and then we have a final linear acceleration of 0.1 meters per second squared. So for this one, the problem didn't end up being too complicated. As usual, we want to label all of our known variables, label our unknowns to make sure everything is organized. Turns out we had to use 3 different formulas for this one. One with all a bunch of angular values, and then 2 that's going to help us translate some of our stuff into some linear values. Now let's take a look at our second one. It says a circular saw spins from rest. It has an angular acceleration of 2.5 radians per second squared. What is its final angular velocity, and how many complete revolutions does it complete? So let's go ahead and clear some space before we solve this second problem. All right, so for this one, we have an omega I value of 0 radians per second because it starts from rest. We know that the alpha is 2.5. And if I'm looking at all of our values there, that looks like it's about it. But now that I'm looking at the original question again, we're missing one more value that should have been written in the problem, which is a time of 15 seconds. So let's go ahead and squeeze that in. All right, now let's go ahead and find the final angular velocity. So if we want the final angular velocity, we could use the same formula we used a little bit earlier. We can use this formula in green right over here because we have everything we need. So let's go ahead and work that one out first. All All right, now that we got that one taken care of, we just multiplied both sides by 15, and we have an omega final value of 37.5 radians per second. Now, the second part is a little bit trickier. It says how many complete revolutions does it complete? So what we want to solve for is we're going to want a delta theta so we can see how many radians it spins through, and then we'll convert those radians into revolutions with one secondary step as well. So if we use our delta theta formula, it looks like this. And it looks like we don't need this front portion because everything starts at rest. So let's go ahead and solve for our delta theta and then convert that theta into revolutions. All right, so we know um, how many radians our saw has spun through, 281.25 radians. And all we have to do is one little conversion from there because we know that there are 2 pi radians per circle or per revolution. So we did a quick little conversion there and got our radians canceled and then turned that into revolutions by taking our answer of 281.25 and dividing by 2 pi. And we got an answer of 44.76 revolutions. Now it says how many complete revolutions is it complete? So that is very, very close to 45, but it does not complete that 45th revolution. So our answer is 44. So when working out these problems, you want to make sure you label everything, set everything up, to keep your values organized. And then from there, you're going to have to use a couple different formulas in order to find different solutions. But I hope that was helpful to you. Thank you for watching and listening.